Hi guys, welcome back to math class. I'm going to show you how to do a quadratic equation with a coefficient other than 1. This is page 11 in your packet. And basically the idea is that if the coefficient of the x squared is something other than 1, it's not going to look like your traditional beautifully symmetric. It's still going to be symmetric and everything, but it's not going to look like your normal, what you're used to parabola when you graph it. It's going to have a flip, which is the same as a reflection, or it's going to have a stretch, which is the same as like a dilation. So to do this, we have to pay attention to that coefficient. So the first thing I do is I only look at the first two terms and I want to pull out that coefficient. Hopefully it is going to leave you with something nice, but it doesn't always. But you have to pull a 2. It has to be a 2. The 16 is awesome because it works out great. But if that was a 15, you still got to pull the 2. Okay, so the first thing that I do is I factor out the 2, but only from the first two terms. So, 2 times x squared minus 8x, that would equal 2x squared minus 16x, just a little division. Okay. Now, I always move the 30 to the other side. I just like it out of the way, but you don't have to. You could leave it just outside the parentheses. All right, so now what is in the parentheses, I'm wishing for that to be a perfect square trinomial. So I do negative 8 divided by 2, and then I take that negative 4, and I square it, and that's 16. So I'm going to put 16 in here. But you really have to think about that, because that looks like a 16. But it's not really a 16 because that 16 is going to get multiplied by the 2 with the distributive property. So it's really 16 times 2, which is 32. So when I add on the other side, I'm adding a 32. Because I didn't add 16. I added 16 times 2. So that gives me y plus 2 is equal to 2 times the quantity, x minus 4 squared. And now it's basically just move the 2. And that's vertex form. All right, one more time. So I'm looking only at my first two terms, and I want to pull out the 5. So I'm identifying that this is the same as 5 times x squared plus 4x, and then plus that 23. It has to be the 5. So even if it creates a decimal or a fraction inside the parentheses, you have to pull the entire quadratic term's coefficient, the whole thing. Okay. So now I'm going to move that 23. And again, you don't have to. This is something I like to do. And I have x squared plus 4x plus, I don't know. Okay. So half of 4 is 2. 2 squared is 4. So I'm going to put a 4 here. But that's not really a 4. It's really 5 times 4. So I really added a 20. The distributive property. So that gives me y minus 3 equals 5 parentheses x plus 2 squared. And then I just move the 3. And that's it. It looks much harder than it is. It does take a little bit of abstract thought because you have to think 5 times 4. What did I really add? Now you can check this on your graphing calculator. So I'm going to check the first one for you. So I want to enter this in a couple of stages just so that you can see it. So I started with entering standard form. Remember, standard form is descending order. So I have the quadratic term, the linear term, and then the constant term. And then I typed it in when I factored out the 2 from just the first 2 terms, just from the quadratic and the linear term. And just to show you that these are equivalent. Same picture, same graph, same equation. Same input, same output, same equation. And here you can also see the vertex is 4, -2, which I can double check. 4, -2. Yep, it's 4, -2, so I definitely did that right. And now I'm just going to check my final answer. So I'm going to add a third one in here. And this is my final answer, which is written in vertex form. 2 parentheses, x subtract 4, close parentheses squared, subtract 2. Graph. Yep, all 3 are equivalent. That means that I am definitely correct. And I can find my vertex right here at 4, -2. I can find my vertex right here on my table at 4, -2. I can find my vertex right here in the formula that shows vertex form. Standard form, partially factored form, vertex form. Page 12 is practice of this. Page 12 is optional, but I would hope that you do it and you practice. If you have any questions at all, please reach out, and I hope you're having a great day.